All right, hello, this is Geometry Section 1.5, Angle Relationships. Definitely encourage to pause the video as it goes along in case I'm going too fast and you don't have time to write things down or go back, whatever you need to do to get it. Opening up with a definition, which there'll be quite a few in this lesson, for adjacent angles. And if you're not too familiar with the word adjacent, a really good way to think about it, adjacent pretty much just means next to. So if objects are adjacent to each other, we usually just think that they're next to each other. Specifically with angles, these are two angles that lie in the same plane and have a common vertex and a common side. So there are two requirements for what's common. Common vertex and a common side. But no common interior points, which would imply that they don't overlap. So they're right next to each other, but they're not on top of each other. So angles that I'm going to label here and draw this, angle A, point A, sorry, B, C, and let's put a D there. So the two angles that I see that would be adjacent would be angle ABC and angle, naming this one CBD. Reminder, when we name angles, the vertex goes in the center, and there you go. A linear pair is a pair of adjacent angles with non-common sides that are opposite rays. So they're adjacent, meaning they have to be next to each other. They share a vertex, they share a side, but they don't overlap. And linear, we know, means they form a line. So that's another way to think about this, is just they form a line. Sorry, I don't know what was going on with that letter there. So these two angles, let's say I've got X, Y, Z, and then up here I'll have point Q. So I could say angle XYQ and angle QYZ. So those two angles form a linear pair. So together they make a line. I kind of think about almost like puzzle pieces, like if I slide, let me highlight real quick. So if I take this piece that's pink and I slide it together with this piece that's yellow, when I fit and interlock those pieces together across this part, I get a nice perfect straight line. And we'll deal with the numerical aspect of that pretty soon. Vertical angles we looked at a little bit last time when we looked at what congruent angles look like. These are two non-adjacent angles formed by intersecting lines. So they're non-adjacent, meaning they don't share a side and a vertex, but they do share a vertex. So whenever you draw two intersecting lines, you will create two pairs of vertical angles. Like here we have the top and the bottom, and then you also have the left and the right. So the green ones go together, the pink ones go together. So just to have some letters on here, let's say that that's A, the central point's B, over here we have C, let's say that's D, and F. Vertical angles are always congruent. You don't have to measure it, you just know for a fact if you've created two intersecting lines, the vertical ones are congruent. So I could write angle ABD is congruent to angle, the bottom one, FBC. And likewise, the left and the right, angle ABF is congruent to angle DBC. So always going to be the same, and whenever you make lines, you'll have two pairs. So that is vertical angles. So example one, just kind of putting this into play, find the value of the variables, and I would pause it at this point, give yourself some time to draw that. I'm going to go ahead and get started. What stands out to me to begin with is that these two angles both have x, and they're vertical. So I'm going to label with arcs to show that they're congruent, and that tells me I can set up 3x minus 10 equal to 2x plus 25. And then do a little bit of algebra to isolate our variable, minus 2x, minus 2x. Go ahead and add the 10 at the same time. Cancels out, cancel out. So we're left with x equals 35. So we found x already. Then I'm looking at the y. I don't have the angle across from it, so that's not going to help. But I do know that these two make a line. And because they make a line, we can kind of remember that lines equal 180 degrees. So I could plug the 35 in, maybe do 2 times 35 plus 25, which would give me 95. And then I know that these two are a linear pair. They make that line. So I could set up 5y plus 95 equals 180, because together they make a line. Subtract the 95 over, get that 5y equals 85, divide by 5, so then we know that y equals 17. And then there's our two answers. We have y, and we have x. All right, definitely pause at this point and write down those three questions and also draw that picture. When everybody's got it drawn and written, go ahead and unpause it, and I'll show you what we can get for our answers. So, first one says, name a pair of adjacent angles with E as the vertex. So I'm thinking maybe angle AEB. And that would share a side with angle BED. And there are other ways that you could name those. That's just what I came up with. But it looks like that would be the two that have that as its vertex. I guess you actually name this one too. All right, name a pair of acute vertical angles. So we don't have any measurements here, so we're going to kind of eyeball it. Scanning around the picture, these two look like they would work. So I could call this one HDG, angle HDG, and opposite of it, the other one it's paired with would be EDB. And then finally, what angle would form a linear pair with angle CBF? So finding CBF right there. So I'm looking at, well, this one would. So EBC. Like some questions that we've had so far this semester, it's not like there's going to be just one correct answer on these. So as long as your answer works, it's good. Next two definitions, complementary angles. Complementary angles, two angles with measures that have a sum of 90 degrees. Two angles with measures that have a sum of 90 degrees. And I thought this was too funny not to post it in the notes. So 90 degrees, you'll often see those in a pair of angles that form a right angle. Not that it has to be that way. And then supplementary angles are also very common. Two angles with measures that have a sum of 180 degrees. Two angles with measures that have a sum of 180 degrees. So applying these, pause it at this point and write down this example. Then I'm going to get started. Find the measures of, marking some things that are important, supplementary angles. So before I read anything else, I already know this, that my angle plus my angle is going to equal 180. Because that's what supplementary means. They have a sum of 180. If the measure of one angle is 6 less than 5 times the measure of the other angle. And I don't know what either of those are, so I'm going to assign a variable to this other angle and just call it x. And this one says it's 6 less than 5 times that, so that could be 5x. 6 less would be minus 6. And I'm going to put those in those blanks I put there. So x for the other angle, and then this one's 5x minus 6. And then work it out, combine my like terms. X and 5x become 6x minus 6 equals 180. Add the 6 over. So 6x equals 186. Divide by 6. And x is 31, which partially answers it. But the question said find the measures of the angles. So this is one of them. So 31 degrees would be one answer. And like we're kind of getting used to get our other answer, usually we're just going to plug in. So I'm going to go back here and do 5 times 31 minus 6. So 5 times 31 would give me 155. Minus 6 would give me 149. At this point, I would just look at my two numbers, and that helps me be pretty confident that we did this correct. Because if I take 149 plus 31, I do get 180, which is what's supposed to be going on. So our answers are supplementary. What I would not recommend you do, we could have just done 180 minus 31 to get that 149, but then you kind of lose that opportunity to check yourself, because then if your 31 is wrong, then this number is going to be wrong, you're not going to know it. So I would recommend you take this answer, plug it back into the original, then verify that they work. Perpendicular lines, just a reminder on what these are, they intersect to form 4 right angles. So 2 lines are perpendicular, they do intersect specifically at a right or a 90-degree angle. Kind of a reminder if we need it, when you want to label that an angle is right, you just put a little box in one of the corners. And if you see an upside down capital T, that is the universal symbol for perpendicular. And then a thought real quick, if this angle is a right angle, I know this one is a right angle because they're vertical and they have to be the same. And then I would know that this one and this one are also 90 because these two are a linear pair. They have to add up to 180, and if you do 180 minus 90, you're going to get 90. So you don't have to label all of them, because if one of them is 90, it's guaranteed that all 4 of the corners will be 90. Example 3, again, pause the video at this point, get this written, and when we are ready, go ahead and press play to move on. Find the value of x so that line M, reminder that means perpendicular to line N. So if these two are going to be perpendicular, that's got to be a right angle. So we would know that 10x minus 10 must equal 90 degrees. Add 10, add 10. So 10x equals 100. Divide by 10. And x, 10, kind of the magic number on this problem apparently. Then find the value of x. We have done that, so that is our final answer. So rest of the block is yours to work on the assignment. If you need to go back to the notes, though, definitely feel free to rewatch anything that you may have missed or that seemed too quick.